Over the last few videos, we've created functions and classes to load in our own custom dataset. And we learned that one of the biggest steps in loading a custom dataset is transforming your data, particularly turning your target data into tensors. And we also had a brief look at the Torchvision transforms module, and we saw that there's a fair few different ways that we can transform our data. And that one of the ways that we can transform our image data is through augmentation. And so if we went into the illustration of transforms, let's have a look at all the different ways we can do it. We've got resize, it's going to change the size of the original image. We've got center crop, which will crop. We've got 5 crop. We've got grayscale. We've got random transforms. We've got Gaussian blur. We've got random rotation, random affine, random crop. We could keep going. And in fact, I'd encourage you to check out all of the different options here. But, oh, there's auto augment. Wonderful. There's random augment. This is what I was hinting at. Data augmentation. Do you notice how the original image gets augmented in different ways here? So it gets artificially changed. So it gets rotated a little here. It gets darkened a little here, or maybe brightened, depending how you look at it. It gets shifted up here, and then the colors kind of change here. And so this process is known as data augmentation, as we've hinted at. And we're going to create another section here, which is number 6, other forms of transforms. And this is data augmentation. So how could you find out about what data augmentation is? Well, you could go here, what is data augmentation? And I'm sure there's going to be plenty of resources here. Wikipedia, there we go. Data augmentation in data analysis are techniques used to increase the amount of data by adding slightly modified copies of already existing data or newly created synthetic data from existing data. So I'm going to write down here, data augmentation is the process of artificially adding diversity to your training data. Now, in the case of image data, this may mean applying various image transformations to the training images. And we saw a whole bunch of those in the Torchvision transforms package. But now let's have a look at one type of data augmentation in particular, and that is trivial augment. But just to illustrate this, I've got a slide here ready to go. We've got what is data augmentation, and it's looking at the same image but from different perspectives. And we do this, as I said, to artificially increase the diversity of a data set. So if we imagine our original image is over here on the left, and then if we wanted to rotate it, we could apply a rotation transform. And then if we wanted to shift it on the vertical and the horizontal axis, we could apply a shift transform. And if we wanted to zoom in on the image, we could apply a zoom transform. And there are many different types of transforms, as I've got a note here. There are many different kinds of data augmentation, such as cropping, replacing, shearing, and this slide only demonstrates a few, but I'd like to highlight another type of data augmentation, and that is one used to recently train PyTorch Torchvision image models to state-of-the-art levels. So let's take a look at one particular type of data augmentation used to train PyTorch vision models to state-of-the-art levels. Now, just in case you're not sure why we might do this, we would like to increase the diversity of our training data so that our images become harder for our model to learn, or it gets a chance to view the same image from different perspectives so that when you use your image classification model in practice, it's seen the same sort of images but from many different angles. So hopefully it learns patterns that are generalizable to those different angles. So this practice hopefully results in a model that's more generalizable to unseen data. And so if we go to Torchvision, state of the art, here we go. So This is a recent blog post by the PyTorch team, how to train state-of-the-art models, which is what we want to do. State-of-the-art means best in the business, otherwise known as SOTA. You might see this acronym quite often. Using Torchvision's latest primitives. So Torchvision is the package that we've been using to work with vision data, and Torchvision has a bunch of primitives, which are, in other words, functions, that help us train really good performing models. So blog post here. And if we jump into this blog post, and if we scroll down, we've got some improvements here. So there's an original ResNet 50 model. ResNet 50 is a common computer vision architecture. So accuracy at 1. So what do we have? Well, let's just say they get a boost in what the previous results were. So if we scroll down, there is a type of data augmentation here. So if we add up all of the improvements that they used, so there's a whole bunch here. Now, as your extra curriculum, I'd encourage you to look at what the improvements are. You're not going to get them all the first go, but that's all right. Blog posts like this come out all the time, and the recipes are continually changing. So even though I'm showing you this now, this may change in the future. So I just scrolled down to see if this table showed us what the previous results were. Doesn't look like it does. Oh no, there's the baseline. So 76, and with all these little additions, it got right up to nearly 81. So nearly a boost of 5% accuracy. And that's pretty good. So what we're going to have a look at is trivial augment. So there's a bunch of different things such as learning rate optimization, training for longer. So these are ways you can improve your model. Random erasing of image data, label smoothing, you can add that as a parameter to your loss functions, such as cross entropy loss, mix up and cut mix, weight decay tuning, fixed res mitigations, exponential moving average, which is EMA, inference resize tuning. So there's a whole bunch of different recipe items here, but we're going to focus on one. We're going to break it down. Let's have a look at trivial augment. So we'll come in here. Let's look at trivial augment. So if we wanted to look at trivial augment, can we find it in here? Oh yes, we can. It's right here. Trivial augment. So as you'll see, if you pass an image into trivial augment, it's going to change it in a few different ways. So if we go into here, let's write that down. So let's see this in action on some of our own data. So we'll import from Torchvision, import transforms, and we're going to create a train transform, which is equal to transforms.compose. We'll pass it in there. And this is going to be very similar to what we've done before in terms of composing a transform. What do we want to do? Well, let's say we wanted to resize one of our images or an image going through this transform. Let's change its size to 224, which is a common size in image classification. And then it's going to go through transforms. We're going to pass in trivial augment wide. And there's a parameter here, which is number of magnitude bins, which is basically a number from 0 to 31, 31 being the max, of how intense you want the augmentation to happen. So say we only put this as 5, our augmentation would be of intensity from 0 to 5. And so in that case, the maximum wouldn't be too intense. So if we put it to 31, it's going to be the max intensity. And what I mean by intensity is, say this rotation, if we go on a scale of 0 to 31, this may be a 10, whereas 31 would be completely rotating. And same with all these others, right? So the lower this number, the less the maximum upper bound of the applied transform will be. Then if we go transforms dot to tensor, wonderful. So there we've just implemented trivial augment. How beautiful is that? That is from the PyTorch Torchvision transforms library. We've got trivial augment wide, and it was used, trivial augment, to train the latest state-of-the-art vision models in the PyTorch Torchvision models library or models repository. And if you wanted to look up trivial augment, how could you find that? You could search it. Here is the paper if you'd like to read it, how it's implemented. It's actually a very, very, I would say, let's just say trivial augment. I didn't want to say simple because I don't want to downplay it. Trivial augment leverages the power of randomness quite beautifully. So I'll let you read more on there. I would rather try it out on our data and visualize it first. test transform. Let's go transforms, compose. And you might have the question of which transforms should I use with my data? Well, that's the $1 million question, right? That's the same thing as asking which model should I use for my data? There's a fair few different answers there, and my best answer will be try out a few, see what worked for other people like we've done here by finding that trivial augment worked well for the PyTorch team. Try that on your own problems. If it works well, excellent. If it doesn't work well, you can always, oh, excuse me, we've got a spelling mistake. If it doesn't work well, you can always set up an experiment to try something else. So let's test out our augmentation pipeline. So we'll get all the image paths. We've already done this, but we're going to do it anyway again, just to reiterate. We've covered a fair bit here, so I might just rehash on a few things. We're going to get list, image path, which is our, let me just show you, our image path. We just want to get all of the images within this file. So we'll go image path.glob. We'll glob together all the files and folders that match this pattern. And then if we check, what do we get? We'll check the first 10. Beautiful. And then we can leverage our function from before to plot some random images. Plot random images. We'll pass in, or plot transformed, random transformed images. That's what we want. Let's see what it looks like when it goes through our trivial augment. So image paths equals image path list. This is a function that we've created before, by the way. Transform equals train transform, which is the transform we just created above. That contains trivial augment. And then we're going to put n equals 3 for 5 images, and we'll do seed equals none to plot, n equals 3 for 3 images, not 5. Beautiful. And we'll set the seed equals none, by the way. So look at this. We've got class pizza. Now, trivial augment, it resized this. Now, I'm not quite sure what it did to transform it per se. Maybe it got a little bit darker. This one looks like it's been, the colors have been manipulated in some way, shape, or form. And this one looks like it's been resized, and not too much has happened to that one from my perspective. So if we go again, let's have a look at another 3 images. So trivial augment works, and what I said before, it harnesses the power of randomness. It kind of selects randomly from all of these other augmentation types and applies them at some level of intensity. So all of these ones here, trivial augment's just going to select some at random and then apply them at some random intensity from 0 to 31, because that's what we've set on our data. And of course, you can read a little bit more in the documentation, or sorry, in the paper here. But I like to see it happening. So this one looks like it's been cut off over here a little bit. This one, again, the colors have been changed in some way, shape, or form. This one's been darkened. And so do you see how we're artificially adding diversity to our training data set? So instead of all of our images being this one perspective like this, we're adding a bunch of different angles and telling our model, hey, you got to try and still learn these patterns even if they've been manipulated. So we'll try one more of these. So look at that one. That's pretty manipulated there, isn't it? But it's still an image of steak. So that's what we're trying to get our model to do, is still recognize this image as an image of steak, even though it's been manipulated a bit. Now, will this work or not? Hey, it might not, but that's all the nature of experimentation is. So play around. I would encourage you to go in the transforms documentation like we've just done, illustrations. Change this one out, trivial augment wide, for another type of augmentation that you can find in here, and see what it does to some of our images randomly. I've just highlighted trivial augment because it's what the PyTorch team have used in their most recent blog post for their training recipe to train state-of-the-art vision models. So speaking of training models, let's move forward, and we've got to build our first model for this section. I'll see you in the next video.